Hello, we are Team 5. We will start presentation about Burj Khalifa. Our team member is 장민지, 허성원, 이진웅, 신용택, and the presentator are 최현준 and 변상국. We will gonna talk about lot of team members, weekly plan, geology and stratigraphy, foundation method, and testing. This is a lot of team members. 이진웅 and 최현준 had researched about foundation. 신용택, 변상국, 장민지, 허성원 had researched about testing. 최현준, 변상국 are presentator, and 장민지 makes PPT design. In the last weeks, we had shown a structure and design, and today we will present about foundation. We will start with summary of last week. Last week, we prepared a survey on design and structure, and we checked the needs of device identity and the buttress core. We have also confirmed that there are various issues, and we would like to learn about the foundation associated with them. Before looking at the foundation method, we should search the geology and stratigraphy of the site. The geology of the Arabian Gulf area has been substantially influenced by the deposition of marine sediments, resulting from a number of changes in sea level, and mobile sand beaches, vaporizer deposits, and marine sand also formed a weak base in Dubai. Next, we searched about Dubai stratigraphy. It consists of sand and weak sandstone up to 24 meters below ground, and weak limestone from 24 meters to 50 meters. In other words, you can see that most levels are weak. Below, these are weak sandstone and limestones which are unsuitable to support the structure. Dubai's ground is also low, because the surrounding area is mountainous. Therefore, it is located at a level closer to underground water than other ground. In other words, there is a possibility of groundwater flooding when working on the foundation. Let's take a look at this video about flooding. If the destruction occurs, underground water may be flooded into the site of the destruction, which can be linked to corrosion and lead to major accidents. As a result, it is important to ensure the long-term stability of the building foundation. In summary, the ground in Dubai, where Burj Khalifa is located, had two problems. First, it has a weak ground. Special measures were needed to build skyscraper in the weak desert. Second, it is close to underground water. Special measures were also needed to prevent groundwater from penetrating. There are two methods to solve Dubai's weak ground. First, fire foundation. This is a way to support lift and reduce subsidence. Let's take a look at the details of this method. Pile foundations are used in the following situations. First, when there is a layer of weak soil at the surface, and this layer cannot support the weight of the building. Second, when the building has very heavy, concentrated loads, such as in a high-rise structure, bridge, or water tank. Burj Khalifa is satisfied with both of these situations. The end-bearing piles pass through weak soil and rest on strong soil layer, hence behaving like a column. Friction piles work on different principle. The pile transfers the load of the building to the soil across the full height of the pile by friction. In other words, the entire surface of the pile, which is cylindrical shape, works to transfer the forces to the soil. Let's find out the concrete piles of Burj Khalifa. They are materials of pile foundation. The number of piles used were 194. The piles were 1.5 meter in diameter and have a length of 47.45 meter. Each pile has a capacity of 3,000 tons, and the concrete grade used in piles were C60 SCC concrete, which were placed by tree method. The concrete mix for the piles was also enhanced, designed as a fully self-consolidating concrete to limit the possibility of defect during construction. The diameter and length of the piles represent the largest and longest piles conventionally available in the region. The 6,000 tons pile load test also represented the largest magnitude pile load test performed to date within the region. The friction files are supported in the naturally cemented calcite conglomerating formation, developing an estimated ultimate fire skin friction of 250 to 350 kilopascal.
Next, left foundation. To overcome weak ground, left foundation also used. A left foundation, also called a mat foundation, is essentially a continuous slab resting on the soil that extends over the entire footprint of the building, thereby supporting the building and transferring its weight to the soil. This reduces the stress on the soil. In Burj Khalifa, the left foundation has a thickness of 3.7 meters and was constructed in 4 separated pours. The grade of concrete left is C50, which was self-consolidating concrete called SCC concrete. The concrete volume used in left is 12,500 meter cube. By using C50, it makes steel bars and concrete stronger. In this slide, material of foundation. Special concrete pour were used for left and pile foundation. SCC concrete is a highly flowable, non-segregating concrete that spreads into place. Also, it fills formwork and surround is the most congested reinforcement without the use of any mechanical vibration. So, it allows innovative architecture plans and improved constructability. Next, pour enhancement strips. Before pouring SCC, there is special steel frame structure as known as pour enhancement strips. The pour enhancement strip is consists of 2 layers, primary bar layer and secondary bar layer. The construction of left foundation was completed by pouring SCC into the steel frame structure. And summarizing previous slide is, pile and left foundations are important factors that make the world's tallest building safe despite the poor geological conditions in Dubai. Also, there is an element that further maximizes safety. And the picture shows that there are many reinforcements to connect left foundation with the pile foundations. To use method, there are many benefits. First, pile left foundation reduces the settlement comparison with left foundation. Second, pile left foundation is more economic foundation when compared to pure pile foundation when considering bearing capacity. Also, groundwater is one of the problems. To solve this problem, the trimming method utilizing polymer slurry was used. Let's see this video. This technique is to fill the borehole with viscous polymer slurry, pushing underground water and lock pieces to the edge of the borehole and leaving them open. But a more serious problem here is the high level of corrosive groundwater, which is about 3 times saltier than seawater. As such, it was necessary to corrosion prevention plan of anti-corrosion measures in order to ensure the long-term integrity of the tower's foundation system. First, we implemented a special water flow system across the left and pile foundation. Second, we increased the cover of the concrete surrounding the level. In addition, preventive measures were taken to add corrosion inhibitors to the concrete mixtures and implanted a cathode protection system using titanium mesh. In this slide, there are testing methods to ensure stability. First, test of pile foundation. After the pile load settlement test in 2004, the expected setting value was measured by the hyperbolic function for load settlement curve and the given load settlement curve. When designing, limit state design was used. After choosing maximum value and setting that value as a design value, the construction was started. And it's hard to see the difference clearly with the previous graphs, so you will understand well if you look at this graph. The black line is the estimated amount of settlement, and the red line is the 80% of the building's total. This shows that the actual amount of settlement was lower than the maximum estimated settlement obtained from the given load settlement curve. The engineers were confident that their foundation was playing its role. Also, the actual ultimate part skin friction capacity remains unknown, as no faults fell during the test program. Next is the test of left foundation. Due to the thickness of the tower left, it was important to limit the peak and different temperatures due to the heat of hydration, so as to accurately determine left concrete mix design and placement method. Large-scale test cube of the concrete mix, 3.7 meter on a side, were poured prior to the left construction in order to verify concrete placement procedures and monitor the concrete temperature performances. In this slide, concrete testing. For concrete testing, there are many testing programs for all concrete types needed for the project. For example, mechanical properties, including compressive strength, modulus of elasticity, and split tensile strength, and durability test, and creep and shrink test, and water penetration test, permeability test for all concrete mix design. And also, there are many laboratory testings. The geotechnical laboratory testing program consists of two board classes of the test. First, conventional test, including moisture content, Ethelberg limits, particle size distribution, specific gravity, unconfined compressive strength, point load index, direct shear test, and carbonate content test. Second, sophisticated test, including stress pass triaxial, resonant column, cyclic undrained triaxial, CNS, direct shear test. These tests were undertaken by a variety of commercial, research, and university laboratories in the UK, Denmark, and Australia. By testing, the Burj Khalifa can obtain stability. This slide is our last part. Thank you for listening.